Alright, welcome folks to the beginning of the fun stuff, Module 1, Basic Ideas and Methods. So, to recap, by this point you should have already gone over the review material in Module 0. You should be familiar with the Blackboard page, you should have confirmed your access to our Applia system, and you should have by now uploaded your example of statistics in the real world to the discussion forum, as well as the algebra quiz to test basic ability. So, here's what we're going to be doing. Again, the main focus of the class is, of course, on statistics, and the basics of statistics is it's a bunch of techniques we use to make sense of data that we get. And you'll hear all about that in the next, several modules. But statistics don't mean much without being put in the proper context. And in this case, the context is how we run our research, how we structure things to get data that's as accurate and as useful as possible. You can know statistics as well as you possibly want, but if your research design is bad, or if you just don't really quite know what you're looking for or how to interpret it, it's not going to be much value to you. So that's going to be our focus today, and we're going to start by talking about some general philosophy behind the process of scientific research and some of the basic terminology and principles that you'll hear about. We'll start with a little bit of context. Again, the original context that we used was to talk about how statistics sort of show up in the real world outside of classrooms and academics and whatever field you're looking for. So I encourage everybody to go look at the responses in the discussion thread. If you've gotten here early and there's not much there, wait about 24 hours or so and come back and you should see lots more of examples, but also look for examples around you. Think a little bit about what are stats trying to do here? How are we using statistics to get information on these topics, and how does it kind of streamline that process? What is it actually telling us? So what information do they provide? Also, you want to go a little deeper, think a little bit about what information those statistics are not providing, but that people still might be really inclined to interpret or to read into those examples. Again, throughout the semester, one of the best ways to kind of understand this stuff is to ground it in real-world examples. Stuff in your field, stuff in your other classes, but also the things that we see around us. We see research reported, we see statistics used continually, we don't always necessarily notice it, but that's going to give you a feel for what these techniques actually look like and how they help accomplish the goals of whatever line of research you're conducting. So, beginning at the beginning, everybody should have heard of the scientific method at some point in time. The scientific method, at its heart, is designed to give us useful, repeatable information about the natural world, the world around us. So we have a little graphic here, why people believe weird things, and it's an interesting book, but one of the main premises of it is just that being a smart person doesn't make you immune from believing irrational, nonsensical things. It usually just means you come up with smarter reasons to justify it. So we can't trust our own intuitions when it comes to understanding other people's minds or understanding the natural world or any kind of scientific topic, because we're biased. We're prone to irrationalities. We're prone to believing things based on shaky evidence, etc. So the scientific method is designed to kind of try to get around that. And at the basis of the scientific method is, or the heart of it, is this idea called critical thinking. You've all heard the term critical thinking before as well, but critical thinking, you could teach an entire class on it, but basically the idea is essentially thinking critically, being able to step outside your own biases, your own assumptions, to look for evidence, to figure out the best way to verify or refute whatever sort of beliefs you might have or whatever sort of predictions you might make. So we don't blindly accept arguments just because they sound good. We don't blindly accept conclusions just because someone smart said them. Again, we need evidence. Show us data. So some of the things that critical thinking does is it examines the assumptions that we are making when we make predictions about human psychology or even things like physical therapy, occupational therapy, some of the other majors that I know folks out there have. We look for hidden values. There's kind of a little story that I like to tell that basically refers to, or basically talks about this stockbroker in Canada in the 1990s, and he was touring people around their offices, which were on like the 28th floor of a skyscraper, and they had these kind of floor-to-ceiling windows, and basically, some of the people touring the place expressed that they, were afraid of heights. And the stockbroker said, "Oh, this is unbreakable glass. This glass is far too strong for any human being to break it with just their body. Like, watch." And he did something that he'd done many times, which is he ran full force at the window and rammed it with his shoulder. Now, here's the thing. This stockbroker was making an assumption. The assumption was that the glass was so strong that he could not possibly break it by running into it with his shoulder. He was right. That was absolutely correct. There was no way he could break that glass physically. There was nothing wrong with it. It was far stronger than any amount of force he could exert. There was also what we'd call a hidden value there, sort of an assumption he was making that he hadn't realized he was making, which was that the window frame would also hold his weight. He didn't think too much about that assumption, but he was making it all the same, and that assumption turned out to be wrong because the unbroken glass popped out of the window, and both he and the window went all the way down to, unfortunately, his demise. So it's a little bit kind of morbid, but it kind of talks about the importance of understanding what sort of hidden values or assumptions you might be making when you're thinking about a scientific topic. But the one we focus the most on has to do with evaluating evidence. Basically getting information and making sense of it. That's the entire focus of the course. Either way, the overall philosophy, don't make assumptions, don't cite authorities, show me evidence. Get good, accurate data and assess it in a way that tells you how supported your predictions, your beliefs happen to be. So here are, speaking of assumptions, some of the basic assumptions we make when using these techniques in psychology. In other fields, these assumptions may not be as strong, but it's still grounded in these ideas. So our assumptions in psychology is that human behavior is first lawful, which means essentially that there are patterns that sort of govern people's behavior. That people's behavior is caused, it's not random, it's something that again happens due to internal and external factors. There are rules that govern and control behavior, and those rules are things that we can discover through well-constructed research. Related to that, we also assume that human behavior is determined. In other words, that there is kind of a cause and effect there, and that those causes and effects are things that exist in the natural world, things that are at least potentially observable. In science, we do not like explanations that hinge on these intangible kind of metaphysical things like your spirit, your soul, your free will. It doesn't mean that scientists don't necessarily believe in those things, or that you can't if you want to be a scientist. It just means they don't have much of a role in scientific explanations, because by definition, they transcend the natural world. They're things that you can't measure, that you can't really assess. They, again, are very, very kind of difficult to pin down and basically impossible to measure in a lot of cases. So we have to believe that people's behavior is being caused by things that we can discover. And related to that, we have to believe that those causes and those patterns are understandable. That we at least potentially, maybe not today, maybe not this year, but at least potentially, we are able to assess those rules and patterns and understand them. We're able to take the appropriate measurements, figure out what those laws are that people are following, what those natural causes are, and we can use them to predict future behavior based on this understanding. If you didn't assume these things, if any of these assumptions break down, at best, scientific study is trivial. It gives you information that's true but not very useful. At worst, there's no point at all and we're all wasting our time here. Please don't run out of the room after you hear that one. That's not the one we tend to bank on. So, a little bit more on research. When we start the process of research, we begin with a question, some sort of thing that we want an answer to, something we want to know more about. There are some characteristics that this question needs to have. It needs to be what's called testable, falsifiable, and parsimonious. So, for example, let's say that I was interested in the relationship between self-esteem and social stress. And I said, I think people with higher self-esteem experience less social stress than people with lower self-esteem. That's kind of my question. I want to turn that into something I can actually assess. First, we'll see if it meets these criteria. So, testable. A question being testable just means, are the key factors what we call variables? Are they things that you could measure, whether directly or indirectly? And we look at them and say, can we measure people's self-esteem? Yeah, the simplest way is we ask them some questions about it. Can we measure people's stress? Yeah, we can ask them questions again, but there's also physical things that happen to people when they are more stressed that we could assess as well. So yeah, we can measure both of these variables. Next is the idea of being falsifiable. Are there plausible outcomes that would contradict the statement or the prediction that we made? So here, we're kind of predicting people with higher self-esteem experience less social stress than people with less self-esteem. Are there outcomes we could get that wouldn't match with that? Of course, there's at least two. We could find that there's no relationship at all between self-esteem and social stress, or we could find that people with lower self-esteem actually experience less social stress than people with higher self-esteem. It's the opposite of what we predicted. Falsifiability is really important because a lot of old psych theories were not falsifiable. They were so kind of abstract and kind of squishy, you could move them around to interpret basically any possible behavior, any possible result. That's why you don't see many people that believe them anymore. Now, falsifiability sometimes seems backwards to people. Why are we looking for things that would kind of contradict what we predict instead of looking for evidence that supports it? It gets into some deeper science of philosophy of science stuff. We'll talk a little bit more about that as we go, but the simple explanation is it's easier to refute things that you didn't predict than it is to confirm things that you did. That's sort of the pop-up book version of it. So this statement is falsifiable. And the next is parsimonious. Parsimonious just means keep things as simple as possible while still answering the question, still getting the information that you want. So keep it as simple as you can. When you look at this, okay, there's only really two moving parts here: people's self-esteem, people's social stress. If we're interested in how those two things relate, that's about as simple as we can make it. So our question here does qualify. Finally, talk a little about terminology. We're going to talk a lot about hypotheses in this course and a little about theories, and you're going to hear these in other classes as well, of course. And sometimes they get used interchangeably to mean sort of the same thing. There is a difference here, and we're going to talk a little bit about what that difference is. So, a theory is what's called an explanation that uses a set of principles, sometimes a set of predictions, that sort of organizes people's behaviors, different events that might occur, and makes predictions about how they relate to each other. So theories are often broad, they're abstract, they're not really specific. They oftentimes can apply to a lot of different contexts. So for our research situation, our theory might be something like high self-esteem creates less stress in a public speaking situation than low self-esteem. A hypothesis, on the other hand, differs from a theory in that it's a little bit narrower and it's a lot more specific. Generally, hypotheses are expressed in terms that are more testable. So here we have self-esteem, we have stress. We haven't really figured out how we're going to represent those things. A hypothesis might take that theory, that theoretical idea, and change it like this. Individuals who report higher self-esteem, see how we're hinting at how we're going to measure it? They're going to report, there's that hint of how we'll measure it again, lower stress levels after being made to speak publicly for 5 minutes relative to those with lower self-esteem. So what is this saying? This is the same idea as the theory, but it's now expressed in a more specific way that gives us a hint as to how we're actually going to assess it. Now, oftentimes the gap between theory and hypothesis is even broader than this because theories are oftentimes so big and cover so much ground that you could generate dozens or hundreds of hypotheses from them. Here, they're pretty much the same thing. They haven't changed a heck of a lot. But generally, a theory is a big picture kind of idea. A hypothesis is a very specific prediction that's derived from that big picture. Finally, we'll hear a little bit in this class about models, and you'll hear about it in other classes as well. A model is kind of much more complex than a theory. It usually involves a lot of kind of interlocking processes that sort of try to explain as much as possible psychological phenomena like people thinking, their belief systems, and their actual actions. They're rarer, they're more complicated than theories or hypotheses. Here's what a really simple model might look like for our self-esteem prediction. Low self-esteem creates heightened anxiety and self-awareness. Notice we've added kind of the reason why that's the case. That contributes to higher stress levels, and then we add another outcome down the line that creates impaired performance. Most models are more complex, they're less parsimonious, so you need a really good reason to adopt a more complex model, because again, you lose a lot of that parsimony. We really won't talk about models very much in this course. You'll hear me mention them now and again, but should you make it to graduate level statistics, you're going to see a lot of models in that case. So that's the end of this introductory piece. Next up, we are going to start discussing the process of how research is devised and actually conducted. So the next place to go is part 1 under the process of research. See you there.